I'm not doing anything else. Blue lighting. I look gorgeous. Oh, we're being linked.
Sure.
Okay.
Wait, can they hear us on like the YouTube thing?
Good question.
I'm doing problem 1. Call dibs. I hope you know this. I'm just saying.
I have unfortunately accepted my fate. My phone on do not disturb.
I have a turtle roll?
No, Ari, that's not what that means. That just means that your name has turtle in it.
No. I'll confuse this for a second. Oh. You want me to add chat relay?
Yeah. To the main room, though, not to ours.
Yeah. Okay. What should
Okay. So we're getting chat relay into the main room. How can I see if you guys can hear us? If you can hear us, if you can hear us, raise your hand in the Zoom. So either our view, I think our view of the Zoom froze, which is not ideal. That's not ideal. I think our Zoom thing froze. Okay. Oh well. And okay. Okay, awesome. So it is nice to meet all of you guys.
Yeah.
Why don't you guys all just say where you're from? My text is flipped. That's not good. That's really not good at all. Well, that seems to be
Cincinnati.
the fix.
I have a cousin that lives in Cincinnati.
Cincinnati. Nice, nice.
San Diego. Oh, wow, we have people from everywhere. California, LA, Tokyo. Actually, whoa, that's cool. I've always wanted to go to Tokyo. Vancouver, Redmond. I don't know where Redmond is. Palo Alto. My math teacher's from Palo Alto.
Oh, nice. Earth. Same.
San Jose. San Francisco area. It's pretty cool. Is there anyone from Minnesota? That's the real
From
question.
China to Dallas.
That's a long move. Whoa. That's a big change.
What was it then? Hmm.
It's a long plane ride. Yeah, wait. I don't know. I moved from Minnesota. What? Why would you move from Minnesota? This is a great state, man. We sit in snow for half the year. I mean, what else do you want in life than snow? If you like LA better, you're burning up there, man. You're like toasting. You're roasting. You're becoming medium rare as we speak. I don't know why I want to live in LA.
Yeah. Well, you know what I think we would want to do? I think we'd probably want to see what great problems we have the glory of solving today. What do you
Brew,
think?
we're doing OIMC today.
Not at all scared. We are going to crush it.
Yep. Yeah, OIMC is a good test. You guys should do the previous years if you haven't. They're good problems. Right. Do you want to get started?
Yeah, you want to take the first question?
Sure. All right. Let's see what we have. Two trains of the same size are driving past each other. One train is driving at 60 miles per hour. The other train is driving at 30 miles per hour. It takes 30 seconds for the trains to pass each other. What is the length of the train? All right. We're going to have some amazing drawings on the board. This is train 1. Okay. And this is train 2. To go from this to basically like this, where the trains are past each other, it takes 30 seconds from this to this. And notice that the trains have to travel like this train. We'll call this T1 and T2. T2 has to go from like the beginning here of the train has to go to the end of the train. And okay, no, that's a terrible way of saying it. The end of T2 has to go to the beginning of T1, which means I have to travel basically like 2 train lengths. I go from here to when they're stacked on top of each other, and then I'll go to this state basically. So T2 is going 2 train lengths. So I travel 2 train lengths, and I'm just going to call it train length x. So I go 2x. 2x is my distance. Each train is like x long. Traveling 2x takes 30 seconds. Okay, how fast is my train going? That's another question. So, okay, well, it doesn't matter how fast each one is going. It matters how fast they're going together, because what happens is one train is going this way at 30 miles per hour and the other one is going this way. Wait, they're driving past each other? Yeah, wait. In the same size one and the other. Are they driving in the same direction or in opposite directions?
Are they going driving past each other?
That's opposite, right?
Yeah, I think they'd be going opposite.
Yeah, okay. So basically, that means that they're traveling at a collective of 90 miles per hour because they're going at each other at 90 miles per hour because this one's going 60, this one's going 30. And they're going a distance of 2x, and that takes 30 seconds. And we can make an equation out of that. So, d equals RT, right? So 2x is my distance equals R, which is 90 miles per hour, times t, which is 30 seconds. 30 seconds is how much of an hour? It's like half a minute, and a minute is like 1/60th of an hour. This is like 1/120, right? Am I doing that right? I think I am.
Yeah.
120. Okay, so that's my thing, and now I solve for x in terms of miles because it's I'm using miles per hour. So I have 45 over 120 miles, which is math. 15 over 40, which is 3 over 8. So each train is 3/8 of a mile. And what is the length?
Is that your
of the
final
train?
answer for the length of the train in feet?
No, it's not. We have some multiplication to do. Okay, so 3/8 of a mile is 3/8 times 5280. Okay, let's think of a good way to do this. What's a good way to do this? Huh. Okay.
You
So
could
we're gonna
divide
do
by 8.
5200 plus 80. Okay, this becomes 10. This becomes basically 52 times 100, which is 52 times 25 over 2, which is 52 times 26 times 25, which becomes, what does that become? Well, this is 24 times 25 plus 50 plus 10. This is 100 times 6 plus 60, which is 660 feet. Okay, there we go. X is 660 feet, which is the train. That's a long train.
Yeah, definitely. Okay.
Let's see if we're right. That's kind of important. Okay, well, they kind of scammed me because they gave me the answer in miles. Well, I guess I'm right. Answer is a little wrong. But it's still 3/8 of a mile. So
yeah.
Okay.
Cool. Okay.
Your turn, Megan.
Woo! Next question. Emily, Emma, and Ella hate those names. Go buy fruit in an organic fruit store. Emily buys an apple, pear, and a banana for $7. Emma buys 2 pears and a banana for $7.50. Ella buys an apple and a banana for $4. Ethan has $10 to buy 2 apples, and he wishes to spend the rest of his money to buy candies that cost 10 cents each. How many candies can he buy? Okay, so basically what it's asking us to do first is to find the price of an apple. So let's set up some systems of equations. Emily is buying an apple, a pear, and a banana. So we can write that as apple plus pear plus banana, and that costs her $7. 2 pears plus a banana is $7.50, and an apple and a banana is $4. So immediately from this and this, I can see that a pear is $3. And if I plug that into this equation, I'll get that a banana is $1.50, and so an apple is $2.50. So then from now, we are just going to say 10, because that's how much money it starts with, minus 2 apples, times the price per apple. And then we're going to multiply that all by 10, because that's how many candies he can buy per dollar. A pear is 50 cents more than an apple. Yeah, that is another good thing to note, because if we look at these first 2 equations, we increase the price by 50 cents when we substitute a pear for an apple. But now that we know how much each of those are, we can get our final answer, which is 50. 50 candies, yes. Scroll down, please. I don't know what to scroll down to. I can scroll down to check the answer, though. And the answer is 50 candies. That is definitely a lot of candy.
Diabetes.
My favorite.
That's a lot of candy. It is a lot of candy.
Don't get cavities, yeah. Brush your teeth, kids.
I have never gotten a cavity. I'm proud of that.
Congratulations.
Anyway, next problem. Problem 5. And actually 3. Well, they're kind of out of order. n integers sum to a number divisible by 4096. However, their average is 2022. What is the minimum possible value of n? Okay, well, we're gonna have to turn this into math. I guess one thing to notice right away is 4096 is 2 to the 12. So if a number is divisible by 4096, it just needs to have 12 2's in it. And here we're also given information that their average is 2022. So if I have like numbers a1 plus a2, blah, 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 all the way to an, this sums, wait, divided by n, yeah, this equals 2022, which means the sum of the numbers is 2022 times n. And that's useful because we have 2022n is equal to the sum, and we want 2 to the 12 to divide 2022. And this is what we want, right? Divisible by, yeah, 2 to the 12 divides this. And 2022 is 2 times 1011 times n. So basically, if this is true, we need n to have 11 2's. Therefore, the smallest possible value of n is just 2 to the 11, which is 2048. Yeah, 2048. And let's assume that all the numbers are 2022. It's easier to count. Yeah. Okay, you can do that too because their average is 2022. That's true. Oops, wrong one. There we go. No, still wrong one. I'm working on it. 1 second. 1 second. Bam.
I got the right one.
2048.
Zaria. Woo! Okay. Good work. Time for our next question about tennis. Arya. Ayo, Arya.
That's not how you spell my name, but I'll take it.
Is that not how you pronounce your name?
It is how you pronounce it, I guess. Yeah.
Yeah. That's what I thought. Arya and Caroline are playing tennis. They have played 20 matches and Arya won the first 8 matches. Arya can win at most 4 games in a row before Caroline beats you. What's the fewest amount of matches Arya can play before she increases her ratio and maintains it to 75%? Okay. So they have played 20. Arya won the first 8. So did she lose the other 12?
Yeah, she does.
Okay, so she lost the other 12. Okay. So Arya and Caroline. So she won 8, she won 12. And then Arya can win up to 4 in a row before Caroline beats her. Okay. So you can go plus 4x plus x, and we need this to be 3 times some number, and this to be some other number. This into clarification. Okay. Okay, so now that we know this, 8 is greater than 4. 8 is greater than 4, yes. I'm not quite sure what that has to do here. Okay. Basically, I'm just going to set up a simple equation to solve this. I'm going to say 8 plus 4x equals 3 times 12 plus x. And this means 4x equals 36, forgot the 8, plus 3x. So x is equal to 28, which means that Arya would have to play, what is that? 1, 1, 2? Yeah, I think that's 112 more matches as the final answer? Or no, because it's not time. It's not how many she wins. It's how many she plays. Okay, 5 times 28. That's a lot easier to calculate. That's 140. Okay, and then let's see if that is the correct answer. It is. Okay, awesome.
Awesome. Okay. Next one. Find the 3-digit number ABC with A greater than B greater than C greater than 0 such that the 5 absolute differences between ABC and any number that is formed by the permutations of its digits sum to 1890. Okay. The 5 absolute differences between ABC and any. Okay. Oh, wow. This is kind of a pain. Okay. Well, my ABC, well, I'm just going to write this as 100A plus 10B plus C. And I have to take the absolute difference between this and all of its permutations. Yay, let's go. Okay. I'll just list them out because it's easier to see then. So I have 10C plus B, and then I have 100B plus 10A plus C, 100B plus 10C plus A, and then I have 100C plus 10A plus B, and then I have 100C plus 10B plus A. And I guess we can figure out to avoid the absolute value sign, since we know A is greater than B is greater than 0, we can figure out which one is bigger of the two and then just swap out around the numbers when we take their difference to avoid that, because absolute value signs suck.
Well, ABC is always biggest, isn't it?
Yeah, but to figure out what the true. Okay, that's facts. ABC is always the biggest. So okay, now we just subtract. So the first one we get 9B minus 9C. The second one we get 100A plus 10B plus C minus 100B minus not true. Right? No, minus 100B minus 10A minus C, which becomes what? This becomes 90A minus 90B, and then the C's cancel out. Okay, this is my second one. My third one is, it's kind of the same thing. It's 90A. Wait, not 90A. It's 99A, and then minus 9C and minus 90B, right? 99A minus 9C minus 90B, yeah. And then my fourth one is 90A plus 9B minus 99C. And then my final one is going to be 99A. 99A, right? Yeah, 99A. Oh man, this is tiring. Plus minus 99C. There we go. Those are my things. And then the 10A's cancel out. So the sum of these equals, what does it equal?
1890.
1890. Okay, so now we just sum this. So we have 99A, 98. Okay, let's see. This is 90. So I have 2 times 99A plus 2 times 90A. That gets rid of the A's, now the B's. I have a 9B, I have a minus 90B, and then I have a 9B. 9B minus 90. Okay, so I have plus 2 times 9B minus 2 times 90B, and then I have a plus, not a plus, a minus 2 times 9C and a minus 2 times 99C. And notice they all have a factor of 2 and they all have a factor of 9, so I'm just going to get rid of that. And this all equals what? 1890. So first they all have, I'll just get rid of the 2 first and then rewrite it. 90B minus 9C minus 99C equals 945. And then that's 105 when you get rid of the 9, right? Yeah, so 105 equals 11A plus 10A plus B minus 10B minus C minus 11C. And then I wonder if there's a more, like, it's not, okay, 21A minus 9B minus 12C equals 105. This all has a 3, so I'm going to get rid of the 3. Minus 4C equals, what does it equal? 105 divided by 3, go.
35.
Factual, I agree. Okay. So now I want this, okay, find the 3-digit number ABC such that this is true. Well, I have, well, okay. I think A is going to have to be pretty big because otherwise when we subtract minus 3B and minus 3C, it's not going to work out well because the lowest case possibility is like 6 plus 4, which is 10, which means that 7A has to be greater than 45. And the only way that happens is if this is 7, 8, or 9. So we're just going to go down the list, starting with 9. Because I don't know. I think we're gonna start with 9. Let's go with 9. I'm feeling 9 today. There's a lot of 9s in this problem. 63 minus 3B minus 4C equals 35. So now, what is 63 minus 35? I'm not
28.
capable of doing this in my head. 1 second.
28.
8. True. I agree with you. Okay. 28 equals 3B plus 4C. All right, now can we find a combination that works? Okay, and we can. And the reason we know this is because, wait. Yeah, we can figure out there are digits B and C that work for this because, well, they're relatively prime, which means we know we can find solutions to this thing, but we don't know if they're less than 10. So we just kind of test it out. And one thing I do notice is that, okay, here's something interesting. This number here is 1 mod 3. So basically, for there to be a solution, we need to subtract some multiples of 4 from this until it becomes a multiple of 4, a multiple of 12, right? And we can do that because we know 24, for example, is a multiple of 12. I mean, a multiple of 12, which means after we subtract like 4C, once we get 28 minus 4C equals 3B, we know that it's going to be divisible by 3 because 24 is, a multiple of 12. So I guess using a coefficients to your advantage is a good strategy sometimes. So we know this has a solution because when C is equal to 1, we have 24 equals 3B. We get 8 is equal to B, which means our number is 9A, 8B, and then C is 1. So it's 981.
Awesome. Well, I should probably double check before I applaud.
Is it? I hope
it is. You got it right, yeah.
I do not want to go through that again. That was a lot of just writing.
Hey, well, lucky for you, it is my turn, and I have, unlucky for me, a geometry problem. Okay, we have a 13, 14, 15 triangle with an inscribed rectangle and a circumscribed circle. And EF is 4. We're trying to find OE.
Oh, I love this problem already. Good old geometry.
Geometry sucks.
It's the best.
Geometry is terrible, and I don't care if you named our chat relay room after geometry today. You were just wrong.
Nah,
do you want the question? I'll switch with you for the next one.
What's the next one? Hold on. Let's check. Oh, yeah, you can. Yep, the next one. Okay. Yeah, okay. My question. I'll take it.
Oh, no.
All right. The next one just seems kind of painful, just a little bit. Well, first, this is a 13, 14, 15 triangle. And a fun fact about that is if you draw the altitude, you get, I'll freehand it because not too good. But basically, a fun fact is here we get 13, 5, 15, 9. And this is a right angle here. And this is interesting because we know EF is 4, right? And since we know EF is 4, we have little similar triangles over here. ADG, that's a triangle, not an A. ADG is similar to, okay, let's call this point X over here, where I drew the altitude, is similar to ABX. Okay. And the reason this is cool is because I can now figure out AG, which will eventually be important because, okay, I guess I'll go systematically. When we look at the problem, you want to figure out OE. So the first thing that goes through your mind should be like, what can I use to find OE? And OE is in kind of a weird place, but the only thing that like aids us is right angles. So I have a hunch that we're going to use Pythagorean Theorem to figure out what OE is. And to use Pythagorean Theorem, there are two things we need. We need legs, right? And we might be able to find, like, there's an obvious to right triangle right here. What?
You drew the altitude from B to AC, right?
Yeah.
Does it go through O?
It doesn't. My lines are just not. I guess that's another thing to keep in mind. The altitude doesn't necessarily go through O, and in this case, it doesn't go through O. My line is just a bit wonky.
Okay.
Here's the thing though. There, if you draw this altitude though down, that is a right triangle, but it's kind of hard to figure out this length and this length. So I want to take a look at a different right triangle, and that is, oh, which one? Hold on. Wait a minute. Okay, my idea is slowly leaving me. Let's think about this. AD, where would it go?
You know, I looked at the one you were so desperate to not solve, and I think it's going to be a really quick solve. So I'm just enjoying watching this.
The 2022 cubed one?
Yep.
Did, but the numbers are so ugly.
No, they're not. I'll show you.
Really? Okay. Well, I'm still gonna keep going with this because I think I just do something better than doing nothing.
Yep.
So using similar triangles, I have AG over 4 is equal to 5 because that's my small leg. If you look at my triangle, 5 over AX. What is AX? AX is 20. AX is 20, which means AG is equal to 1. Neat. I like 1. So AG is 1. And we can do the same thing on the other side. We can do the same thing for FG. And namely, that is basically we have 4 over FC equals 20 over 9. And we get 9 times 4 over 20 equals FC, which is 9 over 5, which is not as pretty, but that's okay. So we have 9 over 5. All right. Interesting. Now, let me think about this. Oh, wait. Whoa, hold on. Wait a minute. Okay, I have a cool idea.
Arya, did you just write that the altitude is 20?
Altitude is 20.
How is it higher than the two sides of 15 and 13?
It's 12. Oh my gosh. Okay. It's 12, not 20. Okay, there we go. Now we have to just restart this whole thing. My bad, guys.
Hey, at least it'll be nice. Please tell me that you can see what 9 times 4 over 12 is.
Well, I have to do this one first. 4 over AG equals 4 over AG equals, what does it equal? 4 over AG equals 12 over 5. 20 over 12.
Where's the 5 coming from?
Because it's this one. Whoa, how do I point?
Oh, you're doing the AGD one?
Yeah.
Oh.
Actually, hold on. I don't think I need to do the AG. I do need to do the AG one. I do. 4 over AG equals 12 over 5, right? Yeah. 20 over 12 equals AG, which is 10 over 6, which is 5 over 3. So this one is 5 over 3. Okay. And Euclidean Geometry and Math Olympiad. That's a good book. EGMO is a good book. You should read it. The next one is, what is the next one? 4 over FC equals 12 over 9. So we have 9 times 4 over 12 equals FC. Bam, bam, 3, 3, 3. Okay, so this becomes 3, which is nice. If this is 3 and this is, oh, guess what? This is 5. Yo, it's a 3, 4, 5. It's kind of crazy.
It was always
Okay.
going to be a 3-4-5 ratio.
I know. I just realized that though.
Okay.
What's next? Okay. Let's see. What are we doing? Oh, okay. Here's what we're gonna do. Okay, this is the right triangle. Okay, remember what I was saying about using Pythagorean theorem at the beginning? Well, we're gonna do that. And the way we're gonna do that, okay. Actually, there are multiple triangles you could use here for Pythagorean theorem, but I'm extra. No, I'm not. Am I? Let's think about this. Huh. Okay. Cheap one's $2. Okay. I mean, Google goes a long way. I'm just saying. Not that I promote it. OE. Huh. Can we figure out what the radius is? Will that help us?
It might.
I still don't see
I
how we're
don't
gonna
know.
get OE. How are we gonna get OE? That's the problem. Oh, these are similar triangles. Oh, okay. I'm actually, my geometry is falling off, man. If we draw this altitude here from this line to here, we notice that EFC and EO and let's call this M for Megan, EOM, they're similar triangles, which is nice. We like similar triangles. And another thing is that a line that is an altitude to that side is a perpendicular bisector of that side, because by definition, that's what it means when you have an like O and then it goes through the side of the triangle, because O is created by the perpendicular bisectors of every side of the triangle, which means we know ME. ME is equal to 15 over 2 minus 5, which is 5 over 2. And now we have similar triangles, which means we can solve for OE. And basically we just set up a ratio now. Ratios are fun, right? I think they are. Okay, so OE. Huh. Okay, which angle is it though? Which one is the 3, 4, 5 side? Oh, it's also a 3, 4, 5 triangle. We don't even need ratios. I just realized. Bro, we don't need ratios. Wow. Okay. So 5/2 is the 3 side of the triangle. And I guess a way you can see that is by kind of taking that triangle, noticing that, and then flipping it over, and then noticing how the ratios match up like this. Just flip the triangle over, imagine it in your head. But basically, we have this triangle here now where O, no, that's not O. This is M. M, E, O. This is 5 over 2, which is also the 3 side of the 3, 4, 5 triangle, which means OE is the hypotenuse X. So we have 5 over 2 over X is equal to 3 over 5. And this is just 5. Okay, 5 over 2X equals 3 over 5. I'm going to move this up here. We get 25 equals 6x. We get x equals 25 over 6. Huh. Is that right is the question. What's the question? What is OE? Okay, that is incorrect. That's unfortunate. Where did I mess up? Wait, what's the question? The question is OE can be expressed as A over root. Wait, what? Yeah, I know it's the circumcenter. Okay. OE is A root B over C. Interesting. we messed up somewhere. Where did we mess up? Huh. Okay. That should be a 3, 4, 5 triangle. Yeah. 3, 4, 5. Megan, do you have any ideas about where we messed up?
Geometry is not for me.
Does anyone in chat have any idea where we messed up? That's a better question.
Oh, is circumcenter not in center?
Yes.
Is it that?
The incenter is always I, it's not O, so no. O is usually the circumcenter. I really don't see where I messed up. Well, okay.
Yeah, and if we don't see, we can move on to the next one.
Give me like 10, 30 more seconds. I need to.
Trying to set a timer.
Okay. EC is definitely, EF is 4. Yeah. EF is 4, EC is definitely 5. If EC is definitely 5,
I'll bet you I can solve the next question in the same 30 seconds.
there's, okay, wait. Why? This is gonna bother me now. Hold on, let's see. The triangles might not be similar.
If they're right triangles that share an
Yeah.
angle, they're similar.
They're similar.
That is 30 seconds, Arya.
Okay, fine. We can move.
Okay.
This hurts my feelings just a
Maybe
little bit.
chat will have an idea. BX doesn't pass O. Yeah, see, that was what I was worried, but I presumed Arya didn't do that.
No, the altitude doesn't need to pass O. I didn't use that in anywhere in my solution.
Okay. Well, in that case, I am going to see how far through my solution of this one I can get in the 30-second timer that I've just started. Just to be clear, this one is asking how to find the prime divisors of this number. So the first thing I'm going to say is, wow, this looks like the expansion of a binomial, not a binomial, like a plus b cubed. I think it's 2022 plus 1 cubed. Wow, look at 4045. Doesn't that look like 2022 times 2 plus 1, making this exactly this? 2023 is 7 times, okay, my timer just went off, but still it is 7 times, how did I immediately forget this? I think it is 7 times 289, which is 17 squared. Correct me if I am wrong there.
It is 17 squared.
Okay, 17 squared. So our factors are 7 and 17, that's cubed, so our answer is 2.
Wow. Yo, that's a clean problem. I like that one.
And yet you were scared of it.
Yeah, it looked ugly at first. Like I just saw numbers and I was like, no.
Yeah. Basically, Arya suggesting to coordinate bash it if you want to try to do that.
No, we're not doing that. I'm
We're not doing
strongly
that?
against bashing. I think bashing is really bad on computational tests. I mean, I guess it's fine. Coordinate bashing is bad. Trig bashing is fine. Berry bashing is also fine. Complex numbers are even better, but not coordinate bashing. Like I can't do math like 1 plus 1. It's just not part of my skills. I'll end up writing 3 every single time I do it, so I just try to stay away from arithmetic as much as I can.
Okay, sure.
Okay, this is interesting. We have right up my alley. Oh, Evan is building a positive integer. He starts out with 1 at the digit 1. Each move, he adds a random digit from 0 to 9 inclusive towards the end. He stops when the integer becomes even. If the probability that the integer is a multiple of 4 is A or B, where A and B are relatively prime, find matrix B. Okay, well, he starts with 1, and that doesn't really matter. It just means you don't end right when you start. But eventually, I'm going to have an even digit. And I guess what's important to notice is everything before this is odd because otherwise you would have stopped then. So this is like 2, 0, 4, 6, or 8. And everything before this is 1, 3, 5, 7, or 9. And now we list them out and see which one gives us a multiple of 4.
Do you not just remember your divisibility rules for multiple of 4?
What?
The divisibility rules for multiple of 4.
What is it?
If you have
if
the last digit is 0, 4, or 8, then it preceded by an even. If the last digit is 2 or 6, it's preceded by an odd.
Yo, how do you know this? Okay, that's a thing. But if you're like me and you don't know what that is, you just figure out all the things. Wait, actually, hold on. I found something interesting.
What'd you find?
It might be interesting. Is it interesting? 10. 10. Ooh. No, it's not interesting. Yeah, we're listing it because that's how we do things on my side of the Zoom call. So
okay.
12, 10, 14, 16, 18. Basically, this, and this is not working. So we have 2 in our running count so far. And we just do the next digit. Oops. 8.
Here, Arya, in an attempt to dissuade you from writing out all 25 of these, if you add 20, then it doesn't change whether it's divisible by 4. If you go from 1 to 3, 3 to 5, 5 to 7, 7 to 9, so you're just going to get the same ones at the same time. It's always going to be 2 of them for each of the 5 odds.
That's okay. I agree with this. I agree with this, and I think that's a much better way to do it. Can you just explain that again for everyone?
Cool. So Arya has already shown that for 1 something, 12 and 16 are the only ones that work. Now, for any of these, if we add 20 to get 3 something, then it is going to be, it's either, if it was divisible by 4 here, it's divisible by 4 here.
Yes.
And if it's not divisible by 4 here, then it is divisible by 4 here. So, since we'll always have 2, each time we increase it by 20, we're always going to have 2. 2 times 5 is
10. Which means your total probability is 10 over 25, which is 2 over 5.
Woo!
Yay. Is that right?
Well, what's 2 plus 5?
7.
Is 7 the answer?
I can do that. I hope so.
Yes, it is.
Let's go.
Okay.
All right.
I think we're getting to the end of our question set, which is good because
we're going back to the geo if we finish early.
Yes, we can go back to the geo. Evan is on a plane. Woo, Evan. Evan would love being on a plane. Each turn he takes 1 step forward and turns 120 degrees either clockwise or counterclockwise with equal probability. Expected number of turns after which Evan's path first self-intersects. Yes, unfortunately I do not think this is the cool type of plane like the one that, like, I pretend I actually know how to draw a plane. This is what planes look like, right? Woo! It's not like one of those.
What is that?
That's an airplane.
That looks straight out of a car. Dude, that's not an... Okay. It looks like a pufferfish. It looks like a fish.
That is not a pufferfish. It's not a very good airplane, but it's sure not a pufferfish. Oh my goodness. Okay. So, the actual type of plane it is just the sort of plane I'm drawing on, so I can't really draw a 2-dimensional space. So, here we have Evan. Evan says hi. So, Evan walks like this, and then when he turns 120 degrees, that is going to end him up either here or here. So basically we're looking at if Evan was on a hexagonal grid. No, I cannot put a hexagonal grid. That's unfortunate. Okay, so Evan is at a hexagonal grid and he will self-intersect if, well, okay, doesn't really matter which way he goes here, but so let's just assume he goes here. After that, he could either go here, in which case he's done after the 3, or he could go here, in which case he is free to choose again between here and here. And after that, once again, you can come back, or he can go. I'm not sure, because it's definitely not the case that he will only intersect with the most recent thing. But
wait, I think it is. I think it is like that.
Oh, is it?
Because here, when you go here, he's not gonna intersect with this path again. Like once he goes here,
Yeah.
the only way he intersects is if he goes here. If he goes here, it's like a different thing. And the only way he intersects here.
Like, what if he goes up here, right?
Yeah.
1, 2, 3. Oh no, because it would. It would. Okay, yeah, no, because you're always going like this. So okay, yeah, no, I can agree with that. So in which case, basically, so his first 2 moves are free of charge. After that, we have a 1/2 chance that he dies on his first one, plus a 1/2 chance that he lives and gets 1 plus, and then basically just this whole infinitely thing goes in here. So that is 2 plus 1/2 plus 1/2 plus 1/4 plus 1/4 plus ... So that is 2 plus 1 plus 1/2 plus ... which is 4. Because the sum as you raise powers of 1/2, starting at 1/2 is 1. 2 plus 1 plus 1 is 4.
Okay, I'm gonna a different way to think about it. I'm gonna propose. Kind of the same thing, honestly, but it's a different way to come to the conclusion of 4. Okay, first 2 don't matter, obviously, right? I mean, I think we've made that because it's a bisymmetry. The first 2 moves don't matter. Mm-hmm. So I'm here. At this stage, I either go and win, or I do another move and end up at the same stage I was before, which is I can move to win or not die. Notice how I'm saying win and not die. We got to be positive. I believe in Evan. Empowerment. Evan empowerment. I'm just saying. Anyway, we're at the same state, like kind of. If you think about it as like position, where you're either one away from winning or one away from restarting to your previous state, which is the state you're in right now. And we can write this as an equation. If we say like the expected value of this state, and this state is you're one away from winning, or if you don't win, you're going to be in the same state again. The expected value of you winning from this state, E, is equal to 1/2. Okay, that's the expected number of moves that you're going to go here, because you're going to go here with probability of 1/2 plus a 1/2 chance that plus a 1/2 chance that you're going to take one more move, and then you're going to be 1 plus, and then from this state it's E again, because you're at the same state. 1 plus E. And notice that this is true because, you're either gonna go to the thing or you're gonna come back to the same state you were in. And here we get e equals 2 if you just solve for it. And what's important here is you have to take the first two free moves into consideration because that's not a part of your like state shifting equation. So you get 2 plus 2 and then you get 4. Yeah.
Cool. Yeah, that is a.
There's another way to think about this, like another way. If you guys are, we have time, right? Do we have time?
Yeah, we have 3 more minutes and no more questions. I mean, I've got a lovely end screen that suggests that you join our WeChat and newsletter and the Po-Shen who is on tour.
Okay, there's one more way to do it. I'm gonna go over this. And the other way to do it is kind of just summing up a bunch of different possibilities, which are how many moves does he take before he gets back? If he takes 3 moves, if he takes 3 moves, there's like what is it called? There's a 1/8 chance that he takes 3 moves. If he takes 4 moves, it's gonna be like
a 1/8?
A 1/16. Yeah. Like he gets back in 4 moves. There's a 1/8 probability of that happening. Is that wait?
1/2?
Okay, I'm trolling. I'm actually trolling so hard right now. Oh my. Okay, it is 1/2.
Yeah.
There's a 1/2 probability he goes back. Okay, and if it's 4, it's 1/4 basically. And notice at any n, if he does it in n moves, it's 1/2 to the n minus 2. And the expected value is just going to be n times 1/2 to the n minus 2, which means your total expected value is you summing from n equals 3 to infinity of n over 2 to the n minus 2. And this is a somewhat of a fancy sequence, but it's not too bad because if we say s is equal to 3/2 plus 4/2 squared plus 5/2 cubed and so on, we can say 2s is equal to 3/2 squared plus 4/2 cubed plus 5/2 to the 4 and so on. And we can subtract the first sequence from the second sequence because we have 2s minus s. We just end up getting s equals what do we get? Hold on. No. Wait a minute. Yes, okay. S equals, we're gonna get minus 3/2. Wait, what is a negative? Wait. Oh, okay, that's why. This is not 2s, this is 1/2 s. I'm dividing each thing by 2, so it's 1/2 s, not 2s. Which means when I subtract the second sequence from the second sequence from the first sequence, I get 1/2 s equals 3/2 plus 1/2 squared plus 1/2 cubed. And notice how everything else is just 1 over blah, blah, blah. And I can multiply by 2 now to get s equals 3 plus, like what Megan had, 1/2 plus 1/4 plus 1/8, so on. And this is an infinite geometric sequence, which has some 1/2 over 1 minus 1/2, and this becomes 1, which means s equals 3 plus 1, which equals 4. There you go. Yeah. That's another way to do it.
That's definitely a lot of ways to do that. Okay. Well, it is 5 p.m. if you live in the correct time zone. If you don't, it is still the end of the live stream. Thank you guys so much for coming, and I hope you guys had fun. Again, there are QR codes on my screen if you are interested in our newsletter or in our WeChat. Yeah. Arya, you have anything you want to say?
Come back for more live solves.
You come back for more live solves. No clue about a raffle. EST is not better. PST is better. Thank you, Aiden.
No coast is the best coast. Get it right.
Okay. Well, goodbye, y'all.
All right. Bye. Can I email you to discuss?
Goodbye, dear children.